Hello everyone. So we studied statements in the last video of syllogisms. And now is the time to focus on conclusions. So in this video we are going to focus solely on conclusions. So as we already know that there are stages of solving syllogisms. The first one is statements that we have already read and understood about, and the second one is conclusions. So in statements we read there were three important words that we need to understand, which are all, some, and no. While in conclusions, there are two types of conclusions, which is positive and negative. Now, the positive conclusions consist of all and some, while the negative conclusion consists of no and not. But before we dive into what are positive, what are negative conclusions and how to deal with them, first we need to understand how to check the validity of a conclusion. This is very important. Now what it says is that for a conclusion to be valid, it should be valid in every possible case. So conclusion must be valid in all the possible cases. This means if we have a conclusion 1 right here, and if it is valid in 1 case, 2 case, 3 case, 4 case, 5 case, but if it is invalid in the 6th case, then the entire conclusion becomes invalid. So you can have a conclusion which is valid in 1 lakh cases, but if it is invalid even in 1 case, then the entire conclusion becomes invalid. So in syllogisms, we are not actually looking for valid cases, we are looking for invalid cases. And if we can't find any invalid case, then we assume that our conclusion is actually valid. So what are we looking for exactly here? We are looking for invalid cases, and if we can't find them, then our conclusion is true. Okay, great. Now let's look at the validity of a conclusion when our conclusion is positive. Now if the conclusion is positive, no changes allowed in mod, and we need to check it as it is. So if a conclusion is positive, we are not going to make any changes in mod. And what is mod? Mod is our minimum overlapping diagram, which we studied in the last video. So no changes allowed in the mod, and we need to check it as it is. So if there is a conclusion like sum x or y, so if the conclusion is around sum x or y, then our mod will be for the statements would be this x and y, and we need to check everything as it is. We cannot make, so if our statement is sum x or y and we are making this diagram which is our mod for this particular statement, then we need to check the conclusions as it is in this particular minimum overlapping diagram. We are not allowed to make any changes in this diagram if our conclusion is positive. But if our conclusion is negative, then we can make a change. As you can see, it says if the conclusion is negative, a change in mod is allowed. Although this does not mean that it is necessary to do the change. What are we talking about? So we can make a change in the mod, but this does not mean that it is necessary, that we have to make a change. It's not a compulsion, okay? We can do it. But when we will make this change, how will we get to know? So the purpose of the change is to find the invalid case. So purpose of the change is to find an invalid case. Okay, great. Now let's look at the validity of a conclusion when we have the either or case. Now this is a special case. Okay. Now here the conclusions cannot be both true or both false. So conclusions cannot be both true or both false. And how to check for either and or? Now to be very honest, you have to check for either and or even before you check what the statements are saying. Okay. So this is the first thing you do when you get the question. You check for either or. And if there is an either or case, then you do it in either or scenario. And if it not, you solve it normally as we have learned till now. Now how to check for either and or? In either and or, the subject and the object must be the same in any order. Okay, so in the conclusions, the subject and the object must be the same. For example, this conclusion is that all x are y. Here x is the subject and y is the object. Now in both of the conclusions, the subject and object must be same. although their order can be interchanged. The next criteria we have is the conclusion should be in one of the three formats. So conclusion should be in one of the three formats. So either it should be a combination of some and no, either it should be a combination of some and some not, or either it should be a combination of all and some not. Let's understand it first of all by looking at an example. So here is our example question. Our first statement is all the theorems are therapies. The second statement is some therapies are sponges. Now first we need to check for the either and or case. Now here as we can see that theorems sponge. Now this subject object. As you can see in both of them subject and object is the same and they are in a particular order. This means the criteria 1 follows. Now we also know that the starting is no plus sum. Okay, so here is no plus sum. As you can see, sum plus no plus sum. Now this is one of the formats in which either and or questions will be presented, and they are presented here in that way. This means criteria 2 follows. So here both of the criteria are followed. This means that we have an either or question. Now let's start solving this with the help of a Venn diagram. Now all theorems are therapies. So all theorems are therapies. So how do we draw it? First, this will be my theorems. And this will be my therapies. Now this would be now some therapies are sponges. So first we have already established that all theorems are therapies. So all theorems as we can see here are therapies. Next is some therapies are sponges. Okay, so obviously we are going to go for making a mod here. So here we make a mod and here. So this is some therapies are sponges. Great. So this is the mod. Okay. Now we have to look at the conclusion. The first conclusion says that no theorem is a sponge. No theorem is a sponge. As we can see clearly from our mod as we have presented here that no theorem is a sponge. So this is correct. The second statement says some theorems are sponges. As we can clearly see that no theorem is a sponge in this diagram. As you can clearly see that no theorems are a sponge in this particular diagram. Okay, and if because they are not, this means that conclusion 2 is not valid. But we already know that it is an either and or case because criteria 1 and criteria 2 follows. Now if we look at criteria what our task is, now our task is to make sure that our valid statement becomes invalid and the invalid becomes valid. Here now our job is to make our conclusion 1 invalid and conclusion 2 valid. Now how do we do that? We do that by spreading sponges Venn diagram to therapies. And while we do that, we need to understand that none of the statements should be contradicted or should be proved wrong. The above statement, these statements should not go wrong. Here when I spread the diagram till therapies, none of them actually got wrong. Here still all theorems are therapies and some therapies are sponges. Here both of the statements still follow. Great. Now when we look at the diagram once again, we can see now that no theorem is a sponge. As we can see now theorem is a sponge, so now this is invalid. Some theorems are sponges. Now this follows, so this is valid. So thus this is an example of either and or case. So here the answer will be either case or conclusion 1 or case 2 follows. This would be the answer to this particular question. Great. Now with this we have come to the end of our video, and I'm sure you must have understood by now that what are the statements, what are the conclusion, how to make the mod, and how to go about all of these questions. In the next videos we are going to solve a lot of questions together to understand the concepts better.